So Bernoulli's formula. So integral u dv, which is equal to uv minus u dash v1 plus u double dash v2 plus minus u triple dash v3 plus etc etc, where u dash, u double dash are the successive derivatives of u, and v1 v2 v3 are successive integration of dv, right? So we'll see the problem. Find the Fourier transform of capital F of x defined by f of x is equal to 1 minus x square if mod x is less than or equal to 1, 0 mod x is greater than 1, and hence evaluate integral 0 to infinity x cos x minus sin x by x cube cos x by 2 dx. So we know Fourier transform of f of x, which is given by f bar of p, which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power I p x f of x dx. Therefore f bar of p, which is equal to 1 by root 2 pi, we are splitting into 3 integral, because capital F of x, that is f of x, is given by a 1 minus x square in the interval mod x is less than or equal to 1. Mod x is less than or equal to 1 means x lies between minus 1 to plus 1. So f of x is 1 minus x square only if x is lies between minus 1 to plus 1. All other interval, its value, f of x value, is 0. So that is why we are splitting into 3, right? Minus infinite to minus 1 up to minus 1, then minus 1 to plus 1, because minus 1 to plus 1 f of x has value 1 minus x square. The balance part f of x value is 0, then 1 to infinite, right? So dx plus 1 by root 2 pi integral minus 1 to plus 1 e power I p f of x dx plus 1 by root 2 pi integral 1 to infinity e power I p s f of x dx. That is equation number 1. Given f of x is equal to 1 minus x square, that is x lies between minus 1 to plus 1, 0 otherwise, right? So this is true. From 1 and 2, f bar of p, which is equal to 1 by root 2 pi integral minus infinite to minus 1 e power I p x into 0 dx plus 1 by root 2 pi integral minus 1 to 1 e power I p x, because we are substituting the value of capital F of x. Capital F of x has the value only in the interval minus 1 to 1. So in this integral, my integral minus 1 to 1 e power I p x f of x is 1 minus x square, right, into dx. So remaining integrals, f of x value is 0. 1 plus 1 by root 2 pi integral 1 to infinite e power I p x 0 into dx. Therefore f bar of p, which is equal to 1 by root 2 pi integral minus 1 to plus 1 e power I p x 1 minus x square dx. We are going to evaluate integral e power I p x 1 minus x square dx by using Bernoulli's idea, right? Or otherwise you can use normal integration by parts, integral u dv, which is equal to uv minus integral v du. So here I am going to use Bernoulli's formula. So integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc etc. Take u, which is equal to 1 minus x square, and dv, which is equal to e power I p x dx. Now u dash, which is equal to, so derivative of u, that is derivative of 1 minus x square, that is equal to minus 2x, and u double dash, which is equal to derivative of u dash, that is derivative of minus 2x, that is equal to minus 2. Now v, which is equal to integral dv, that is equal to integral e power I p x dx, e power I p x by ib, right? And v1, which is equal to integral e power I p x by ip into dx, right? So that is equal to 1 by ip is constant, take it outside, integral e power I p x dx, which is equal to 1 by ip e power I p x by ip, that is equal to 1 by I square into 1 by p square e power I p x, that is equal to minus 1 by p square e power I p x. Now v2, which is equal to integral, take minus outside, 1 by p square e power I p x dx. So 1 by p square e power I p x integral e power I p x by ip. So therefore we will get minus 1 by I p cube e power I p x. So we are going to use these values to evaluate the integral. So f bar of p, which is equal to 1 by root 2 pi integral minus 1 to plus 1 e power I p x 1 minus x square dx, which is equal to 1 by root 2 pi. So first uv, u is 1 minus x square, v is e power I px by ip. So limit is minus 1 to plus 1 uv minus u dash v1, u dash is minus 2x and v1 is minus 1 by p square e power I px, limit is minus 1 to plus 1 plus. Then u double dash is minus 2, v2 is minus 1 by ip cube e power I px, limit is minus 1 to plus 1. So that is equal to 1 by root 2 pi 1 minus x square e power I px by ip minus 1 to plus 1, limit minus 2x 1 by p square, so minus into minus plus e power I px, limit is minus 1 to plus 1, again minus into minus plus 2 into I by 1 by I p cube e power I px, limit is minus 1 to plus 1. So we are going to substitute upper limit and lower limit. 1 by root 2 pi 1 minus upper limit 1 square, that is 1 e power I px into 1 by ip minus lower limit 1 minus minus 1 square, that is also 1 e power ip minus 1 by ip. Second term minus 2 into upper limit 1 by p square e power ip 1 minus 2 into lower limit minus 1 by p square e power ip minus 1 plus third term 2 into upper limit 1 by ip cube e power ip1 minus 2 into lower limit 1 by ip cube e power ip minus 1. So first 1 minus 1 0, 1 minus 1 0, so total term 0. Second term minus 2 by p square e power ip plus minus into minus 1, right, plus 2 by p square e power minus ip plus then fourth term 2 by ip cube e power ip minus fourth term 2 by ip cube e power minus ip, which is equal to 1 by root 2 pi minus 2 by p square e power ip plus e power minus ip. So we are 2 by p square minus 2 by p square, right, common, take it outside, so e power ip plus e power minus ip. The second term 2 by ip cube is common, take it outside, e power ip minus e power minus ip. So we know e power ip plus e power minus ip by 2 is equal to cos p. Therefore e power ip plus e power minus ip, which is equal to cross multiplying 2 cos p. Similarly e power ip minus e power minus ip by 2a is sin p. This implies e power ip minus e power minus ip, which is equal to 2i sin p. Substituting these values, f bar of p, which is equal to 1 by root 2 pi minus 2 by p square 2 cos p plus 2 ip cube 2i sin p, that is equal to 1 by root 2 pi minus 2 into 2 4 cos p by p square plus 2 into 2 4 by p cube, I and I cancel sin p, that is equal to 4 by p cube root 2 pi, taking 4 by p cube outside, so 4 by p cube root 2 pi into minus the first term you are having p square in the denominator, so you need one more p, that is why we are multiplying with p, minus p cos p plus sin p. So f bar of p, which is equal to, so 2 root 2, because 4 it can be written as 2 root 2 into 2, so root 2 and 2 get cancelled, so remaining you will get 2 root 2 in the numerator. Take that minus outside, minus 2 root 2 by root pi, right, p cos p minus sin p by p cube. That is equation number 3. We know that from the inversion theorem, inverse formula, f bar of p, which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power ipx f of x dx, then using the inversion formula, so f of x is equal to 1 by root 2 pi integral minus infinite to plus infinite e power minus ipx f bar of p dp. So we are using 3, right, in this f of x is equal to 1 by root 2 pi integral minus infinite to plus infinite e power ipx. We know from 3 f bar of p is minus 2 into root 2 by root pi p cos p minus sin p by p cube dp, that is equal to minus 1 by root 2 pi 2 root 2 by root pi integral minus infinite to plus infinite e power minus I px p cos p minus sin p by p cube dp. that is equal to, that implies, so we can cancel root 2 root 2, so root pi into root pi, pi in the denominator, minus 2 by pi integral minus infinite to plus infinite e power I p x p cos p minus sin p by p cube into dp, that is equal to f of x. But f of x we know that is given 1 minus x square when modulus x less than or equal to 1, 0 when mod x is greater than 1, right? Therefore minus 2 by pi integral minus infinite to plus infinite e power I p x p cos p minus sin p by p cube dp, which is equal to 1 minus x square when mod x is less than or equal to 1, 0 mod x is greater than 1. So multiplying both side by pi square, so minus pi by 2, sorry, by pi by 2, right? Minus pi by 2 into 2 by pi integral minus infinite to plus infinite e power minus I p x p cos p minus sin p by p cube into dp, which is equal to pi by 2 into 1 minus x square when mod x is less than or equal to 1, 0 when mod x is greater than 1. Multiplying with pi square, so pi by 2 into 1 minus x square, right? Multiplying with pi by 2 with each term on the right hand side, so pi by 2 into 1 minus x square when mod x is less than or equal to 1, then 0 mod x is greater than 1. So pi and pi can, now pi and pi, left hand side pi and pi cancel, 2 and 2 cancel, so you will get minus integral minus infinite to plus infinite e power minus I p x p cos p minus sin p by p cube into dp, which is equal to pi by 2 1 minus x square mod x is less than or equal to 1, 0 mod x is greater than 1. So minus integral minus infinite to plus infinite cos e power minus I px can be written as cos px minus I sin px, Euler's formula, right? Into p cos p minus sin p by p cube into dp, right? Which is equal to pi by 2 1 minus x square mod x is less than or equal to 1, 0 mod x is greater than 1. So that is equal to minus integral minus infinite to plus infinite p cos p minus sin p p cube cos px dp. We are splitting into two integration, minus into minus plus, plus integral minus infinite to plus infinite p cos p minus sin p by p cube I sin px dp, which is equal to pi square 1 minus x square mod x is less than or equal to 1, 0 mod x is greater than 1, right? That is equal to, that is equation number 4. Now p is an odd function, cos p is an even function, so p cos p is an odd function, and sin p is an odd function, so p cos p minus sin p is an odd function. So p cos p odd function, sin p odd function, so when you subtracted or add two odd function you will get odd function, so p cos p minus sin p is an odd function. Now 1 by p cube is an odd function, p cos p minus sin p odd function into 1 by p cube odd function, product of two odd function you will get even function, is an even function, and sin px is an odd function, so p cos p sin p by p cube into sin px is an odd function, right? Because p cos p minus sin p by p cube even function, sin px is an odd function, product of even and odd which gives odd function. So using them by properties of definite integral, integral minus infinite to plus infinite odd function, whatever the function, which is equal to 0, value is 0. So p cos p minus sin p by p cube sin px into dp, which is equal to 0. So 4 implies minus integral minus infinite to plus infinite p cos p minus sin p by p cube cos px dp, then other term is 0, right? Which is equal to pi by 2 1 minus x square mod x is less than or equal to 1, 0 mod x is greater than 1, that is equation number 5. Put x is equal to 1 by 2 in 5, so you will get minus integral minus infinite to plus infinite p cos p minus sin p by p cube cos p 1 by 2 dp, which is equal to pi by 2 1 minus 1 by 2 square, right? So that is equal to pi by 2 1 minus 1 by 4, that is pi by 2 4 minus 1 by 4, that is equal to 3 pi by 8. Therefore integral minus infinite to plus infinite p cos p minus sin p by p cube cos p by 2 dp, which is equal to minus 3 pi by 8. That is equation number 6. Since p cos p minus sin p by p cube is an even function, cos p by 2 is an even function, so p cos p minus sin p by p cube into cos p by 2, product of two even function, is an even function. By properties of definite integral, integral minus infinite to plus infinite even function, which is equal to 2 times integral 0 to infinite that even function. So that is equal to 2 times integral 0 to infinite p cos p minus sin p by p cube cos p by 2 dp. Therefore 6 implies 2 integral 0 to infinite p cos p minus sin p by p cube cos p by 2 dp, which is equal to minus 3 pi by 8. So that is 0 to infinite p cos p minus sin p by p cube cos p by 2 dp, which is equal to, taking that to the right hand side, so it will go to the denominator, 2 into 8 16 minus 3 pi by 60. Replacing p by x, so integral 0 to infinite x cos x minus sin x by x cube cos x by 2 dx, which is equal to minus 3 pi by 60, which is the required deduction. Thanks.